Hey everyone, how's it going? Hopefully you guys can see me, hear me. Maybe not see me, that's kind of normal. Let's see, do I have audio going through? I do have audio going through. How's it going everyone? How's it going Franco? How's it going Vero? I'm a little, how's it going Adam? A little bit fashionably late. Season's greetings. Happy Merry Christmas, all that stuff. I just got this in the mail right before the stream, this is why I'm late. Google Pixel 7 phone case. You're probably wondering, well, why, if you have a Google Pixel 3a, do you need a case for a 7? I just got a Google Pixel 7. Okay, interesting. So the biggest thing is I got a phone for multimedia creation. I got a phone for, filming videos with and stuff. So I wanted a case with a tempered glass screen protector over the cameras. How's it going? Oh, Kaya. How's it going? Johnny Bergdahl. Sound and vision working. That sounds like a David Bowie lyric. So yeah, got myself a new phone because it's on Boxing Day sale. Way cheaper. I think for the Pixel 7, which is a $680 phone, ended up paying like $200, but spread over 24 months. So it's pretty cool. And also, going to have a little bit of snacks here. Don't know if you guys, Americans probably don't have these, but the British definitely have Cadbury, what are they called? Mini eggs? These are like generic mini eggs. So they're really good. Geez, Adam, you're doing a frickin' marathon. I'm going to show you what's inside the mini eggs. Just candy coated chocolate. So today, just want to show you a couple things. So like this and this, my mic pack right there, USB. I have a ton of these little devices that I need to charge up. And the problem is, to charge all of them at the same time requires a lot of USB ports. They don't have to be high current, but when you think of something like this Apple brick, for example, this is a 1/2 amp. So this would be good. This would be okay if, if you're only charging 1 or 2 of these things. But I kind of want like a bunch of charging at the same time. Here's some more examples. Camera batteries, GoPro batteries. Oh no, this is pencil because it's been hanging around my school bag for a long time. So it actually comes off. Maybe if I had an eraser, it would come off easier. Eraser, all the way under here. There we go. See? All better. So yeah, I have a bunch of things that charge. This one is USB-C or micro. This one is micro. This one is micro. I actually have a couple of these flashlights kicking around. I have those TP4057 modules in a couple things. So I use them to charge. So the basic point is I need a whole bunch of charging at the same time. And so to buy, I actually have some coming from AliExpress. I have some bricks like this that have 4 or 5 plugs, which I think will work in the meantime. But until then, or after that, I want to build a USB charging rig. And so this will be like a section that I will put somewhere. I'll have like a spot for it specifically. And I want to have at least 12 USB, USB-A female plugs. And so I want to be able to have just a bunch of cords there. How's it going, Doug? I'm hopefully no magic smoke, but that's always a possibility. So yeah, I want at least 12, preferably more, USB-A female plugs. And well, how are we going to power that? Well, if I can find somewhere around here, I have a computer power supply. I have no idea where it is. But anyways, on the side of the computer power supply, it does show you how much current you can get out of it. And typically, the 5-volt rail is on the order of like 10 amps. You get like, 10 amps or more on a USB power supply. Let's see. Yeah, Doug's probably, I'm guessing you're working, right, Doug? I'm guessing that's the deal. So the deal is I want to have a whole bunch of plugs that don't need to be high current, but I just want a lot of plugs, a lot of cables, and I'll just be able to plug all my devices all in one spot. So my camera batteries, which are very important for doing the production here. The GoPro batteries also, they're really important for when I go do outings. I can charge 3 at a time here, and I can plug the GoPro in as well, because the GoPro charges USB-C. So that is useful as well. GoPro's somewhere around here. I need to have a big organization. Helping a friend. Well, that's always good. I had to go help my my old man shovel a couple days ago. Probably should have went yesterday too. Whoopsies. I have no idea what's going on, by the way. I had the day off yesterday. I might have the day off tomorrow, and if so, I don't know what to do with myself. That's an idea, Adam. Definitely a possibility, but I feel like they're not that reliable. Also, the form factor is not very compact. So if you think one of those switched USB things is like this big, right, and it only has like 6 on it, I literally want to compact as much as possible. I'll show you what I ordered so far. It's not in yet, but it's basically these USB-A, I believe these are the female side, and I ordered some that are stacked kind of like this. They're 2 in 1, but they're flush, and then all the wires go all the way through. So they actually sort of sit like this, one on top of each other, and that means I can put 6 in a row and I'll get my 12. But what I'm thinking of is actually putting 5 or 6 in a row, and then having another PCB on top with another 5 or 6. Like, I'm going nuts with these things. I am sick and tired of having this USB, too few USBs problem. And I'm also going to go nuts and probably fabricate a whole bunch of my own cables. Dusty Springfield song. Interesting. So That's the goal. Oh, here we go. There's some here. So if you look at this, this is a solar charge controller. See how it has the 2 stacked USBs? That's actually one USB device, but they're 2 stacked, and that's what I've got coming from China. It's a whole bunch of these, and so I should be able to line up a whole bunch on a PCB. And what's great about that, since I've decided on using a PC power supply, I'll be able to break out 12 volts, 3.3 volts, and if I want 24 volts at low current, or negative 12 volts at low current. So the charging station will be one part of it with all the cables coming out, but then I'll also have like outputs similar to, I have my PCB with all the banana plugs. I'll be able to feed that. Where is that PCB? Sort of like this, I guess. So this PCB with all the banana plugs put on it and screw terminals, and I'll be able to like output a whole bunch of these voltages on top of that. So yeah, pretty cool stuff. Make loads of YouTube short during running a blinking LED on as many different pieces of hardware. Yeah, that would be good. YouTube shorts are pretty cool. I need to take the time, since I have time off from work, I need to take the time and reinvest it into my channel, but my body doesn't know how to handle not doing any work, because tomorrow I typically work at the new job I got with the new guy, and then I typically work Saturday at the dealership, but I'm not working Saturday because I gave in my 2 weeks, and my 2 weeks ended last Saturday. So yeah, I'm a little bit floating, I guess. Not exactly sure what I'm gonna do, but maybe I could even live stream tomorrow. Who knows? I have not decided. So PC power supply, we need some way to get the power, and I will show you how I plan on doing that. But yeah, basically today is going to be experimenting with how to get the most current out of these USB plugs. I think you can just short the 2 data pins together on the PCB, but there might be a faster way if you put a resistor in between them. I'm not sure, so we'll see. And I'll probably end up, like I said, making custom cables, power only USB cables, where it's like, you know, like just two short 2 wires, and you know, a female plug, a male plug, and you know, whatever, micro USB or something like that. Well, I'll figure it out at the time, because yeah, I do need a lot of cables, and the cables have gotten ridiculously expensive with this stupid inflation stuff going on. So yeah, and I might actually put a piece of steel in my design, so I can take like this thing, which has a magnet, and stick it on there too to charge. So yeah, that's the plan. Let me show you the parts I got coming from China. Also, don't forget that the human malware right now is affecting China big time, and so things may take forever to arrive. All right, so don't allow, go away. So I've got coming some whatever, ATX 24-pin PCB. So I got these plugs, so these guys here, but just the plug, so I can solder my own. That's a 90 degree. Yeah, that's not what I want. That was not it. Could open, give me a second. I'm gonna open Chrome, another window. orders. I'm just going to grab the order numbers. Oh, this is weird. I can't see you guys chatting. Okay, I got this, and this, and this. All right, so if I grab this, copy, does that show anything? It does not. Okay, gotta bring you back. There we go. All right, so these are the Molex connectors that you would plug your power supply into a hard drive. So I've got these coming. They will go, I'm going to use these footprints here and design that onto the board. So it'll be able, that'll provide the 5 volts. I believe it provides both 12 and 5 and ground. Or is it 3.3? I don't remember now. But yeah, these guys will get soldered onto the board. That's one thing. Then I've got this one. So these are PCIe connectors. They deliver only 12 volts and ground. But this will be good for the distribution on like a power distribution board for high current. So I'll be able to use the 12 volts off the power supply. Ooh, asthma attacks. That's not good. And then I ordered these guys as well. So these are the ATX power supply plugs. I believe there are 5.08 in between each pin, so I'll be able to just solder this onto a board as well. And that should bring me my 5 volt, 12 volt, plus 12 volt, minus 12 volt, 5 volt, 3.3 volt in grounds, as well as the switch power on. So that should be useful as well. Ooh, I got, yeah, package delivered email. And then the last thing is these guys. So pretty much exactly what I said. These guys here. So yeah, I have these double stacked. Where are they now? These guys. I have these double stacked USBs. Oh, did I get these? No, I got the ones that are standing upright. There we go. So these double stacked USBs, so they have 8 pins down there, and then you just solder the big ground planes. And that means that I'll be able to, if I have room for 6 of these on the board, that means I'll have 12 USBs available. So that's kind of the plan here. To get a bunch of these. There's going to be a 3D printed case, and I'll probably bolt it to the wall or something. I'll figure out what's the most useful setup. I wish they came in triples or quadruples. That means my PCB will be much smaller. But I could also make, you know, like solder pads where I can make my own USB cables. Because I don't know if you guys noticed, but let's say micro USB. The micro USB cables have gotten really expensive. Oh, look at this. You make your own cables. No, they're 8 pins. So if you look there, there's actually 8 pins, just because the picture quality is kind of garbage. So you know, each one will have. What I'll do though is I'll probably pour copper around both of these. I'll just make a custom footprint for it and pour copper around both of these so that they actually fit. because I just want a lot of current to be able to go through. But I'm liking this idea because I can make, 10 cables. The thing is, I don't have to go back to these USB things. I could just have solder pads on the board where I can attach like literally 10 of these USB things to like one place. And then I'm just limited by the amount of wire I want to use. That could be an idea. Grab this. See if that's actually the cheapest one. There are the Type-C ones as well. Because yeah, I wouldn't even care about the data at that point. I can just short them if need be. See if we get it even cheaper. It's like, I don't even need long cables, but they need to be able to, not break. You see, 12, like let's say $13 for 10 cables. That's $1.30 a pop. But if the cables don't last very long, that may not be that good of a deal. This is a lot less trouble than trying to make my own, though. That's for sure. See, this is not a bad idea. But the thing is, that would just preclude that my USB port can actually supply that much. Right, if I have more USB ports, it divides the current a little bit. But yeah, this kind of stuff, see, it's just low current charging. So maybe like one cable like this would be useful. This is a listing for 10 though. These are all not bad ideas. Oh yeah, I have power banks as well to charge. Like, I've got lots of stuff that needs to be charged up. It is a pretty good solution. But the thing is, I also like the idea of a charging station, because then I can have one spot in my house just for all these, and I can like even fireproof it if I need to. Like, it could be inside of a metal box. How's it going, Big Z? So yeah, that's the plan, but we're gonna experiment today. USB charging specs. How USB charging works. Let's try that. Okay. USB, let's go micro USB charging data pins. Let's see what that says. I kind of want to know what to do with the data pins, because I know there's like specs for it. Does anybody know a good website where it would actually tell me what to do with the data pins? Because this is kind of what the stream is about today. So micro B is what we're looking at here. So data. Because I do know something does happen when you short the pins. I think you can get more current out of it. But I don't know if there is a resistor. If there's a resistor position where you can get the maximum current, or if is there a resistor I can use to limit the current so I can just, you know, trickle charge things. Let's see. Connector, power, allowable current draw. Let's read that. Power. What? In terms of unit load, which is okay. Yeah, no, I'm not worried about PD. Like you're talking about like QC, like some sort of quick charges. One unit load for the hub controller and 1 unit load for each, at most 4 ports. Yeah. Okay. OTG, power delivery. I just want to get like half an amp over to everything. Voltage, yeah, this is what I'm talking about. Resistive voltage divider between 2 and 3 volts, and then others will short up to their max on a charger with the data pins shorted. Okay. Downstream port signals data as per USB 2.0. 15K pull down resistors on both D plus and D minus. Okay, dedicated charging port. No data transfer, but is capable of supplying currents beyond 1.5 amps. They're short between D plus and D minus. So it looks like I just have to short the... I just need to short the data pins together. So that's it, I just short them together. That's weird. So they do say a 2 meg ohm resistor between 5 volts. Like, that's interesting. So I might actually do that, because I think I just have a bunch of high current resistors, high resistance resistors. Without a voltage dividing network to two shorted data pins, the voltage between them is free to float. Even though you twisted data pairs, some shielding. Okay, I see, I see. So, yeah, so maybe this, so this is for protection. I might do that. I might do this sort of thing. Voltage and currents now done by chips. Yeah, no, I know. I just want dumb, you know, like the TP4057, it just wants 5 volts. So it's that kind of stuff I want. Okay. One day I will design a QC type charger, but that's not today. Today it's just kind of this. I'm going to use this sort of arrangement here. Shorted mode per USB battery charging specification. Yeah, so they get shorted together, but then you use these high resistance resistors, so 2 megs in between them. So that makes sense. No, that'll be 2.5 volts though on this. No, wait, they're shorted. Yeah, they're shorted between each other, so that'll be 2.5 volts. So I might just short them together and then high resistance to ground, perhaps. D plus, D minus, yeah, that does it for them. Cool. So let's see then if we can test that, if we're actually going to get you know, more than half an amp out of it. So let's do it practically. Let's just go to the bench and let's try it. Because, I mean, here we got some USB connectors, so we might as well give it a shot. I have, I can take a look at the charging current with a charger doctor, but I can also just look right on the read-in over here. If the eating of the mini eggs is bothering you, let me know as well. I love mini eggs. These are some generic ones that we got, but they're really good. If I'm being honest, the price of the actual mini eggs are so expensive that if it wasn't for these generic ones, we wouldn't have gotten any. I think I'm just gonna flatten out this part here. These like teeth. Gonna be flattened out like that. And then the other pins are 0.1 inch, so they'll fit exactly into the board like so. They should. Yeah, there we go. Except I put it on the wrong side of the PCB. I'll put it on this side. Nope, this side. Put them in a little bit. There we go. So I just got to turn on my soldering iron. Should probably get my stuff to bring it up a little higher so you guys can see what I'm doing. So we'll first test it with the pins open and see how much current we can draw, and then we will test it with it shorted. This will put my Pink Thing landscape mode. Oh, you picked up a soldering iron. Very nice. Over 100 USB leads and no USB mini connectors. Interesting. All right. So once that heats up, I'm going to solder these. Now, what am I going to use to test the charging? Well, I have a couple of completely dead phones here. So this is my iPhone SE, the older generation one. So the battery should be flat, so that should be good to test. I also have a power bank somewhere around here that I can use for testing. Because I know like dumb loads like this guy here, this will just pull whatever. We'll try it, but they are mini, not micro. So basically it's to charge up all my, like this thing, you know, GoPro batteries. That's in the rubbish bags put out in an hour. Are you throwing away a whole bunch of USB cables? I would never. Am I understanding that correctly? Or are we throwing away a bunch of USB cables? I don't know if we can be friends if you're throwing away a bunch of USB cables. In fact, I'll tell you. See the soldering on there? I just bought myself a real Xbox 360 controller, and I opted for the one that comes with the USB-C cable. Oh, two different conversations. Oh, okay, geez. Oh, crap, it's not even the same person. I have to say, you guys are about 5 feet, the chat is about 5 feet that way. Someday I'll make myself a little monitor around here so I can see the chat, but that day is not today. Okay, so now I need to hook this up to my power supply, so I do need short wires, but I did take some wire from my vehicle wire harness here, so I think I'm going to use that since I'm already, you know, this plug is already useless. You need a TTS system. Yeah, I know. Actually, so there is a bot that is free to use that I'm probably going to get. But the thing is that I have to take some time to set it up. Is there enough light here? Let me. Oh boy, that's too much. There we go. I have to take some time to set it up, so I haven't done that yet. It's called, I think it's called Firebot. Not to be mistaken with the Fire Festival, completely different thing. There we go. So that's power and ground. Now, here's the question. Which one's power, which one's ground? Let's see. You can make yourself a bot that'll put the rubbish out. USB connector pin out. you just not open this in a new tab? There we go. All right, so ground is on male connector, female connector. Ground is on the left. Ground is on the left and power is on the right. So if I'm looking here, oh, need to switch back. Webcam. So ground is on the left. Ground, power. Okay. So ground is on this side. What color for ground? Green. Is green ground or is white ground? You guys get to pick. What did we decide on last time? We decided on this before, where green was involved. We decided green is ground, so I'm going to go with that same convention. Green is ground. All right, let's just pre-tin this. Come on. There we go. Okay, so if green is ground, I'll just solder it to these two pins here. Like so. There we go. And like so. There we go. That should be good. It would be nice to stick this down a little bit for my testing. Do I feel like starting up the glue gun? It's probably for the best. Let's be honest. Okay. So yeah, okay. Jeez, I was just thinking of something, but it doesn't make any sense. All right, let's power up the glue gun. I turned on my flashlight here, this guy here, to drain the battery a little bit. So that'll be good. I'm going to try to charge a couple of the things that I regularly charge and see what we get out of it. Plug in the glue gun. Like so. That's good. And I'm actually going to leave this up like this so we can see more what's going on. And I'll put my charge doctor around here somewhere. I'm going to strip the other end of this twisted pair. So let's see, probably on the 26. That's one. That's two. Okay, and then that I can hook up to the read-in. And green is ground. So I shall make that a ground. White is power. And if we get this wrong, we're just going to fry every frickin' device I put in there. Okay, and then V set 5 volts enter. And then current set, I'm going to put it at 10 amps because I'm feeling bold. And so yeah, this will be our little thing. Just to make Put a bigger cable through to hold the wires? Nah. I don't feel like making dust today, so I shan't. I'll just put a dab of glue there. Okay, so now I need to check my charging box. I should have a USB charge analyzer. Whoa. Uh-oh, the charge analyzer is not in here. The box for it is in here, but it's not in here. Whoops. Sorry, I might have smashed my microphone there. What could I have possibly done with my charge tester? I definitely haven't put it away where it needs to go. So that was pretty dumb, because now I'm on a live stream. I have a load, so that's good. But where is the charge tester? I do know where a worse one is, but I like this one because it's OLED. Well, that's embarrassing. Nowhere to be found. What's the reverse of a miracle? This is a Christmas disaster. There we go. It's not a miracle, it's a disaster. I'm also off camera. You guys can't see me, so I feel more at home. Oh, I just knocked the benchy off the bench. Oh, what's this? Oh, that's not it. Or is this it? I think this is it. I think I got it. This one? I think that's it. Is it at work? No. I don't diagnose USBs at work. Not anymore. Don't work at a dealership anymore. I don't know if I'm sad about that fact. I think I was talking about this with my wife. I really liked working at the dealership, but I like the idea of it. I like the way it used to be. It's not like that anymore. So like, whenever I feel sad, like I mourn the loss of like my workplace. I don't actually need to feel sad about it because I'm not mourning my workplace. I'm mourning what my workplace used to be. It's not like that anymore. It's now a much worse place to work than what it used to be. So there's that. Okay, so here we go. Let's see if I fry my USB charge tester. If I got the polarity. Oh shit. Also, I got to be very careful. I'm going to put some more hot glue because I didn't solder down the wings. So it's actually sitting very loosely up on this board here. I don't want to break the pins off my experiment. Yeah, I'm mourning the idea of it, which is what it is. We used to, I say we. So the shop I used to work at, we used to care about, long-lasting relationships with customers, doing the best quality work we can, offering really high-quality advice, like this repair is cheaper, which is acceptable, but there's a other way to do it, which is more expensive, but will last you 4 times as long, and it's only 10% more. That kind of stuff. And it's not like that anymore. The philosophy is very much get as much out of each customer as possible before they leave now. And so I don't miss that part of it at all. And so yeah, I need to remember that what I miss is the parts that aren't there anymore. So, you know, I kind of wish I would have put more work into my automotive YouTube channel, Dan Fixes Cars, but I haven't actually even started. But I could be at a point today where I have a sponsor similar to PCBWay that would help me open a shop for myself. Now, I do and I don't want to open my own shop. Like, I don't want to run it. That's the issue. I've got enough on my plate, but I would like the freedom to keep helping customers the way I used to. Ugh, sticky. I wish I had something I can plunge this into water with, but whatever. Okay, let's see if I can get this in now. There we go. All right, see if we fry it. It should be on. Do I have the polarities reversed? Well, let us see. Gonna get the multimeter out. This wonderful Fluke multimeter. Let's see. So white should be power and black should be ground. I mean, green should be ground. Literally no voltage is making it up here. What is going on? V set to 5 volts. What the heck's going on here, guys? Am I wrong here? Black to ground? It literally says 0 volts. Is my read-in broken? Uh-oh. My read-in is not working. Oh no, if my read-in is broken, I'm gonna be so mad. I'm gonna try to reboot it. I'm gonna be so upset if my power supply, yeah, the screen is on and everything. On. Oh no, it's not yeah. Okay, here I'll show you. So there's the read-in. So it's on, right? That green light is on, you can see. So it's on, this would be off, this would be on. But it's not outputting any voltage. Oh, frickin' no. What am I? This was literally my favoriteest thing in the whole shop. Okay, let's try to VSET 12, enter. Oh, bugger. What? I can. Yeah, it could be. Could be the fuse. Hold on a sec. Over voltage protection's at 62 and in is 65. What if I try to change? Okay, hang on. Menu. I think it's shift menu. Can you move like this? How do you move? Down? Oh, like this. Oh, no. Shift menu. enter. Oh, this is the memory. Okay, what? How do you change it? Okay, give me a second. Maybe I can go through. I've never had to do this before. Okay, okay. Mem. No. Shift. Okay, Shift M1. Okay. Yeah. Enter. Good. How do you get anything? So I set is there. V set is there. Oh, whatever happened, it worked. Look. It's now outputting. Okay. Jeez. Crisis. I set is 18. I'm going to put it to 10. Okay. Okay, plug everything back in. No more freaking out. You know what? I would be extremely disappointed if it broke, but not that disappointed. And the only reason why I wouldn't be that disappointed, it is I have the RD24 still in the box. But yeah, if I mean, by far the Read-In has been the best power supply I've ever owned, even though it's just the front end. It doesn't have the AC to DC portion, but it's like it's the greatest thing. I would recommend everybody buy one if they're doing electronics. Okay, can you focus, please? Focus. Is that focused? It's not focused. Okay, keep focusing. Thank you. Okay, so now, let's see. Now, the hot's not got time to cool. All right, 5 volts. It is outputting 5 volts now. This thing is not doing anything. Okay, so now back. Are we upside down? So I've got the green in the black, the white in the power, and you see white is on this side. This should turn on. Let me just confirm it turns on with the Apple brick I had. There's the Apple brick. It turns on immediately. So, is it problematic now? Because the data lines are not shorted. Okay, let's try something else. Plug this in. It's drawing an amp now. Now it's drawing almost 2 amps, but the LED is not on. Polarity must be backwards. Let me double check. How could it possibly be wrong when I got it off this random website? Let's see. So ground is over on the left-hand side. I'm looking in here. Oh, socket side. Oh, that's going to make a difference. So, okay, so if the tab is on the top, power is on the left. Tab is on the top, power is on the left. Tab is on the top, power is on the left. It's backwards. Okay, polarity is wrong. Let's fix this. Check my emails real quick. Nope, not sending you a rating. Nope. Nope. All right. So this is actually positive. So actually, these cables are backwards. All I have to do is flip these. That's why you got to check multiple sources. Like so. Like so. And if I plug this in now, power on, it turns on immediately. Okay, now it also tells me I have to go this way, and you guys probably can't see that, but I can read it out for you. So 4.98 volts. I'm just going to adjust the V set to get 5 volts on the dot. There's 5 volts on the dot. I don't know, can you guys see that? Is it too small? It's pretty small. All right, so now if I plug this in at 1 amp, we're pulling 1 amp. We have 4.9 volts pulling 1 amp. And this one, 2 amps. So that's not an issue. You can see it, excellent. Okay, that's good. So that works just fine. Now, my flashlight that I had left on, is very dim. So now let's see if it'll pull a reasonable amount of current to charge. Now what is this? USB-C. I'm going to use a high quality USB micro, which I'm going to come steal off my other project, which I probably should be working on today instead of this nonsense. All right, so plug this into here. These are those PZOS cables. And then here we go. This is pulling more than half an amp. It's pulling, it's dropping down to half an amp, but that's because it's charging. What happens if I turn it on? Pulls even less current. What the heck? What's going on there? But now here's a question. If I short the data lines, does it charge faster? Nope. Same current. Okay. So that's okay. That's fine. This is working okay. Now the thing is to check a cell phone. I'm going to put this screen side down so you can't see my reflection. It's pretty clear. Oh, that's good. So, but you see, this is the kind of, this is what I'm trying to do. Like I have, in this house right now, I have 3 of these flashlights that I would like to charge. I have a bunch of those, you know those proximity lights I made with the TP4056 charging circuitry on it? I want to charge those. I want to charge my mic pack. I want to charge all these things all at once. Okay, so that works. I'm actually going to try something else here. Let's see if we can charge some GoPro batteries. So this will be in here. Not drawing anything. And then I have GoPro batteries from my last time out. Got 3 batteries. Are they all the aftermarket batteries? I'm not sure. Yeah, all 3 are the aftermarket batteries. And so let's see if there's one. That's not charging. Do I have to press harder than that? No, that one maybe just doesn't need a charge. Or are these aftermarket batteries already done for? Well, it's not possible that none of them need a charge, right? Because that is not pulling any current at all. Let me just confirm this with the Apple charger. They're all charging on the Apple charger. Oh, this one might need a shorted data line. No, they're charging now. What the heck is going on here? Because when I plug these in, that actually, look at that, 200 milliamps a pop. They don't charge. Look at that, they don't charge. You have to disconnect and reconnect. That's a quirk of this charger. But yeah, if I plug this in, there we go, 700 milliamps. So you know what? I can leave the data pins floating. We're going to repeat these exercises. You don't need a special charging circuit. Doesn't seem like it. Which is good because my PCB design skills, I mean, they're up to the task, but I don't personally feel like spending all that time. So that's good. I'm going to disconnect this before it charges these all up because this is part of the experiment. And then I have my camera battery, which I will plug into somewhere around here. I've got the camera charger base. Oh, over here. All right. So this guy here. Okay, it pulled, like very quickly, it pulled a couple milliamps. Pulled 26 milliamps. And then I'm just going to plug my camera battery to charge. 1 amp. It pulled 1 amp for a moment. So really, if I just wanted to do basic stuff, I think leaving it open is fine. Okay, going to disconnect this. That's cool. I'm going to put this in the pile that needs to be charged. That's good. All right, I need an iPhone charger now. USB. So the iPhone, I think, is the worst. I mean, I don't either. Don't get me wrong. I don't know how to do it either. But the thing is, I can look it up. So I'm not saying that I know how to do it. I'm saying that I can copy a circuit in KiCad. All right, so I would say iPhones are the most difficult devices to get to charge. They have their own like protocol, their own garbage, really. So let's plug this in and see what happens. So we are pulling 0.5 amp with the iPhone charger. With the aftermarket, this is a non-MFI cable, and the data pins aren't shorted, and we are getting 0.5 amp. Is there anything else that I need to test before I short the pins? But this is all fantastic news. Let me just look around here. If there's anything at all else I need to check for charging. I guess a TP4056 module would be a good thing to test. But that includes, like, I can charge my mic pack. Let's check the mic pack. So right now it's actually being used. I don't know if it'll interrupt. So we'll see. So I can unplug this. Whoops. Just nailed my microphone. Okay, so that's still in shot. Yep. So there's my mic pack being used at the moment. If I plug this guy in. And this guy in. That's charging at an amp. It was charging at an amp. Now it's charging at 100 milliamps. Right? 0.08 amps. So 80 milliamps. There we go. So that is working. I need to find a TP4056 device now. Let's see. Where can I find a TP device? Actually curious to see if it'll power like a micro, because it should just be power and ground. Yeah, it is powering a micro. That's good. Let's see. Can I find a TP device? Should have like PCBs here. I guess not. I thought I had some laying around. Oh, here we go. This one, it should be mostly charged though. I don't think it'll pull much from it, but I can pull the cell and just charge a cell at full power. Oh wait, I did do a TP device. I did my mic. Yeah, so this is working just fine. Okay, that's good. This is the message I would pin. Don't forget to... Here, let me pin your message. I don't know. I think I'd have to give you channel control. A pin message. There we go. Thank you, Vero. Why? What's the for? Is it just because you're editing? This, turn off the output. Oh God, I need my OBS preview. There we go, that's better. Okay, so this is turned off now. And now I'm gonna short these two pins and see if there's any difference. I'm gonna try to short these two pins and then I'm gonna try to link them to ground. There we go. Shorted together. So over here it goes. And then I can put my charge tester. Okay, I can turn off the soldering iron. Because I typed the don't forget message and put a smiley at the end, and only the smiley was sent. So weird. All right, so can we see that? There we go, we got 5 volts. I'm just gonna tip the voltage up a little bit. V set until we get 5 volts on the dot. Oh, 501, 5 volts. There we go. Okay, so a TP circuit. This one pulled about 200 milliamps. So we're gonna see if it pulls 200 milliamps. Yep, same thing. Might be a little bit more. That works. How about my my light? This is more representative of, well, the TP and this, I guess, are representative of what I'd be using it for. So let's plug this in. Yep, 0.6. I feel like we're charging more. I think the big deal will be the iPhone. Let's see, the GoPro batteries. 700 milliamps. You know how yesterday my throat was hurting randomly? I'm getting that now again, randomly. Might make a tea. Yeah, you should probably make a tea. Huh. Interesting. So yeah, this is 600 milliamps. I'm gonna check also the camera battery charging. Half an amp. Am I wrong here, or is this actually charging at a higher current now with the data line shorted? I have to review the footage, but it almost seems that way. Let's check the Apple charger. Again, Apple is like the difficult one in this relationship. No, still half an amp. Well, I think I'm gonna short them to each other. That's for sure. I can also check to see if I can short them to ground, but I think shorting them to each other is decent. Okay, let's try shorting them to ground. See what happens. This is all about experimentation. All right, so turn on the soldering iron again. Let's plop this down to hold it. And the negative is now the white. So all I have to do is do a solder bridge across here. Oh, it's not even hot yet. Okay, so now it's shorted to ground. I don't know what this is going to do. I think the Apple will be the most interesting, so I might start with that. It is ground, right? Right? To white. White is ground. Okay. All right. Here it goes. Plug this guy in. What do we got? Still reading okay. Plug in the iPhone. Okay, still drawing same amount of current, 0.4. So that's good. So I can just short them to ground. I'm not sure if I want to, but I can. .1 amps, and then it goes down to half an amp. Okay. Good to know. The TP module, still okay. 1/4 amp. It honestly seems like it's like incredibly tolerant. You can just do whatever you want with it. Even the micro works. 130 milliamps. And I guess the GoPro was the last. Let's see. Yep, 0.7 amps. So I think we're good. So I think I'm going to short them together and probably put like a 10K ohm pull down, and I'll be able to just remove that if need be on the PCB. It'll be like optional. So I think that's all good. So I guess the next thing I can do is take a look in KiCad and see if we have those footprints available, and if not, we can make them. So that should be pretty neat. Maybe I'll learn how to import footprints. I can take other people's footprints. Screen. All right. So, I'll just move you to the webcam for a moment while I open KiCad. New project. To new, and we'll call this how about USB Chargeorama. All right, and bring you back. Do you have lockets? No, probably the most common lozenges for sore throats would be Halls. These guys. So these are the most common, and then I would say the second most are these, Ricola, because of their wildly successful advertising campaign. So I'd say those two are the most common ones. All right. No, we don't have them available because typically none of our throats hurt. I think the most common one would be me, but mostly it's when I'm teaching and talking a lot. Okay, so let's see what we have for USB here. I mean, at some point it'll open. Plus, I drink a lot of hot beverages. Okay. USB 3, very nice. So USB-A stacked. Oh my god, no footprint for it though. But they do have a stacked thing I can already use. Very nice. So I'm gonna staunchly, so ground is down and the power is up. I'm going to hold on to the fact that I want 6. No karaoke for today. Yeah, I'm not sure what's going on with your sore throat, Vero. I don't think Vero knows either. All right, just gonna tie all these to ground. Yeah, also, Vero feels sick in an odd way. She, well, let's say she doesn't feel sick, usually. And so, we always make fun that her sickness manifests in, like, these strange ways. Gonna short these together. Oh, you got your booster. I need to schedule mine. Probably, if I would have known for sure that I wouldn't be needed at work, I would have done it already. Let's see, plus 5 volts. So I get this one. I did not react well to the boosters. Yeah, Vero is beyond help. Very true. Yeah, I didn't react well to the boosters at all, so I'm not, let's just say I'm not excited about getting it, but I do understand the value of it. I reacted poorly both on the second shot and my first booster. So The first one wasn't too bad. I think the first one was better. I'm trying to remember. It's hard to tell. All right, need a small resistor. Oops, I'm gonna move this. I think these are all together, so I'm going to. How do I want to do this? I don't want to use 2 resistors per. If anything, I want to short. Because I don't want to short them together. But although if you just link them both to ground, I guess. Maybe I'll just leave it out. Screw it. Ah, dang it, Johnny. I know. Fine. 2 resistors. Oops. This one. Whoops. Whoops. This guy. Nope. This guy. And this guy. You know what, I made a mistake. I should have just done all this and then duplicated it instead of, whatever. I don't care. Because now I have to edit all of these individually. Okay, and then like this, like this, like this, like this. Okay, that should be good. Yeah, the new one. Yeah, I agree, Johnny. Here it's the same thing. You get the bivalent one, which is the one that has the up-to-date stuff. Because, like, let's be honest, nobody cares anymore. Like, even if you don't go somewhere crowded, there's so many stories on Reddit of people just like confidently saying they know that they have the human malware, but they choose to go places anywhere. They're like, oh, it's just the grocery store, it's just the movie theaters. I hate people. Like, the thing with the human malware is if people were just not selfish, it wouldn't have been a problem. But people are always selfish. I think that's the issue. Oops, not reference. That's not what I want. Go away. Value. Let's go 10K. I'm pretty sure my parents got it because, my parents got it very recently. My dad actually fainted and fell over and had to go to the hospital for an entire day. And the doctors think it's because of human malware. And I'm pretty sure he got it because they just got a new couch delivered and they didn't, like, the delivery people didn't wear a mask and they didn't ask them to wear a mask. And so I'm almost 100% sure that, I mean, that's the only place. So I'm almost 100% sure that's what happened. Hey, Brian. What you doing slumming it over here? Merry Christmas, Happy New Year. Hopefully your family's good. So yeah, I think it's just people are very selfish, and if they're infected, they're still going to keep doing their own things. And that's why you should probably, you know, see your doctor about if it's a good idea to get boosted or not. All right, so that's done. Let's see, do we have ATX stuff in here? Yeah, they do have the 24-pin ATX. Well, that's pretty good. Ding. All right, 5 volts. Got that there. Ground. Got that there. Ooh, what's 5VSB? Oh, standby. Oh, is that different? They have standby? ATX. Let's see. ATX 24-pin pinout. Oh yeah, 5VSB. Oh, I might hook up one of my things to the standby. Nice. Trip with the family. Where'd you guys go? If you're, if anybody in here is not familiar, Brian Locke was on the podcast. Actually, so was Johnny Bergdahl, now that I think about it. Yeah, well, I have some things to. Oh, let me see. Is it pronounced Galway, like that? I think the GAL makes goal in Irish, right? Or Celtic? Celtic? No, am I saying that right? I don't even know. I'm gonna stop making a butt out of myself. I actually really like the train. There was this one time where I went to see Varro in Toronto, and I took the train. Gall. Okay. Like gallbladder. Galway. Okay. So yeah, I took the train, and it's a 4.5 hour drive to get to Toronto from here. The train was nearly 6 hours, so it's a little bit longer, but it stops. But it was sort of fall, I think, either fall or spring, and the heating was broken in the car. So it was about 14 degrees Celsius in the car, and it was incredibly comfortable. I loved it. It was awesome. I just, you know, did some reading and watched some videos. It was way better than having to drive by myself. It was good. .5VSB. I'm gonna edit 5VSB, and then 3.3. Use a flag. 3V3. And then plus 12V. Whoops, my 3V3 doesn't have the plus. And then PS on and power OK. I'm not sure how to deal with the power OK. Let's see. Power OK, PS on. An hour or so drive was more adventure, but it's very comfortable compared to driving. Yeah. Isn't it nice? You don't have to deal with traffic. You don't have to deal with anything. You just hang out. You don't have to focus on the road. You can write or read, like do meaningful tasks. It's like taking the plane, but except the plane is so weird because you have to go through security. Put an LED on it. Okay, is it positive, Johnny? The train, yeah, you can do substantive work. I mean, in a car, you can listen to a podcast. That's fine. But it's not the same as just switching off and being entertained. Just not the same at all. All right, we are going to use it for an LED then. And then optionally, it'll be pink LED. So we'll go power underscore okay, like so, and we're going to copy paste that. We're going to grab a resistor, whoops, oops, and then we're going to add a LED. Oops. Like so, and then we're going to grab a ground, like so. 5 volts when the PSU is on. Nice. All right, I'm gonna probably 5K is gonna. But I might do 10K. Actually, 10K might be okay. I don't like bright LEDs, but what's brilliant about this is that people can make their own minds. If they make their own PCBs, they can put whatever they want to jack up the brightness. I might actually put a pad for a variable resistor instead too, so you can tune the brightness if it's too bright, and depending on the color of your LED. So I might put a pad for a pot there, and then you can just short, 2 pins of the pot with whatever resistor you want. All right, now PS on needs a switch. So PS underscore on. Sort of like this. It needs a switch, and it also needs a ground. Actually, that'd be really interesting to route this over to a switch that has an LED in it. Could do that too. And then going to... By the way, what are you feeding the troops, Brian, if you're still here? Not that I'm hungry or anything. Not that I'm not like constantly hungry. So PS on needs a switch. Actually, I think it's just a button. No, wait, no, it has to be a switch, actually. It has to be constant on. Just want a switch. Like just generic switch. I do like importing a whole bunch of parts from all over, but it's then much harder to just find a switch. Face. Like microchip switch, yay. Yogurt, oh, okay. So you're not actually making me any hungrier. That's good. How are the dogs, by the way? Now that I know about your family, how are the dogs? You got 2, right? My wife might be semi-paying attention in stream, but she absolutely loves dogs. Well, we both do, but I think she's like next level. We have this dog that gets walked, like the dog walks in front of our house every day, every morning, like really, really early. Her name is Bailey. She looks like a golden retriever, but she looks a bit small for a golden retriever. but she has, you know, long, sort of dirty blonde hair, fur, I guess, and she just loves it. When she sees us outside, she like bolts for us, and then we pet her. Single pull, single throw. How about that? Dual throw. I just want a single pull, single throw. There we go. Like so, and then war to ground. Yeah, dogs are pretty cool. We don't deserve doggos. Okay, so I don't think I'm gonna put any banana plugs on this particular project. So I think I will put the other voltages up to pads. So I'll grab this, actually all of them. All of these guys, they'll go to test points. I'll probably put 2 test points per. Oh, I need ground. So maybe I'll separate these for just ease of viewing. So let's say like ground here, 2, 3, 4, 5. Oh no, you're allergic to dogs? That sucks. Yeah, I kind of wanted that further apart. Oh well, it's fine. Like that. Move. There we go. And now we just want some test points. Whoop. Yeah, like this. 2, 3, 4, 5, 6, 7, 8. So yeah, all these things have test points now. And move them over. You bastard, didn't want to get that J. That. Move them over here. There we go. I think that's about it. So I got my USB double stacks. So that's good. Got my ATX power supply. How many 5-volt pins? This is another thing I was worried about. On a 24 pin, 1, 2, 3, yeah, that's 24 pin. 2 5-volt pins, 3, 4, 5. You know what? I've got enough 5-volt pins then. That's good. I was gonna put a Molex in there to carry more current, but I think if I get 3, 4, 5, I think 5 is enough. 5 plus the standby. That's good. And these commons are grounds. So I think 5-volt cables, they're usually 14 gauge. I think that's enough for like 12 amps, 10 amps. Should be plenty. I'm actually not worried too much about it. All right, so that means we can just, oh, I want these switches to also have test points. So let's do test point. Yeah, it definitely should be plenty. I ordered the Molexes anyways, just because I like to be sure. Where's that connect? Right here. So test point. Another test point to ground. The LED. So actually the thing is I don't need a test point because I can just use the switch's footprint as a test point. So that's okay. Although it'd be nice to do remote switching one day. I'll put test points. They're cheap anyways. Free 99. Like that. The LED is fine. I'm probably just going to replace that with a potentiometer actually. So I can tune the brightness of my LED after the fact if it's too bright. So let's put another pot. Like so. Basically a potentiometer, but used as a rheostat. We're talking about milliamps here, so I'm not worried. So like so, and then like so. And then we're gonna make this maybe a 10K. It could be whatever you want, but I'm gonna recommend 10K. There we go. So that is done. Then basically I'm just gonna use those little through hole pots, the ones you need a little screwdriver for. Not the 10 turns, because that's not necessary for LED brightness. Maybe, man, on mine I might even go 20K on this, or 50K, just because I probably just want the LED to be a faint glow. There's really no need to have a super bright LED to indicate power. I'm just wondering if I should go nuts and put like, this is 6, so I put 2 more. I could easily do it. Because if you think, so if you think of the PCB like this, right? If I can fit, and you think of these stacked USB connectors like this, right? So you can, let's say, oh, where's the transparent one? There we go. So if you, let's say you put all 6 here. 2, 3, 4, 5, and 6. Then you got your ATX connector over back here somewhere. This guy, so let's say ATX there, and then maybe a couple of fuses, whatever. It's not what I wanted to do, but that's okay. Maybe a couple of fuses like there. Then what if you put like another one here facing this way and another one here facing this way, and then you make your box go around like that. car fuses are popular. Yeah, I have PCB mount fuse holders. So people can, if they don't want to buy the parts, they can just bridge it. But I mean, I can put I mean, even a single fuse would be fine, but I could put 4. But yeah, I agree, Franco. That's why I like the resistor. But yeah, so I could make some more that face out, like these face this way, and these face this way, and then these face this way. So I could literally fit like 8 or possibly even 10 on the same PCB. And then obviously they're doubled, so they would actually be, 20 USB slots in one device, which would be awesome. I think that's a bit ambitious though. I don't think you need that, but I could also just put the footprints there and leave them empty if I want to make a 4 version, because if it takes up more board room. Yeah, that's brutal, Franco. I would definitely tape it up too. I hate, I think especially blue LEDs are egregious where they're extremely bright. Yeah, I am using dual height connectors. That's why I'm saying this is already 6, what makes it 12. So that's why I'm debating the egregiousness of putting 10, of putting 8 or 10 double height ones. Because yeah, that would be, it starts to get a little extreme. These are the guys I ordered. Where are they? They're somewhere in here. These guys. So yeah, they are double height. Yeah, I was thinking of that too. There's some here, but that's okay. I don't mind this at all, but then you have to run all that current through a single USB connector, and I think the voltage drop would just be more significant than spreading it out over a whole bunch of these things. You know what I mean? I do agree with you though. That's why I'm also thinking of 4 fuses instead of just 1, which reminds me, if I put fuses, I have to change this or this 5 volts to something else. This has to run through the fuses first. Or else they'll just be, the fuse will be in parallel, which won't do anything at all. So I probably change it here, like this, to 5 volt UF, unfused. You switch to XT60 in the power supply end. Okay, you're connecting directly to a 5 volt source, like a 5 volt power. Okay, you're connecting. Okay, I get you. So you have something coming from the power supply, which connects to an XT60, and that XT60 has a bunch of micro USB ends. I think I'm understanding. I guess also the other thing with me is I'm trying to make it so that people will actually want to use my design, but I think you've got a good idea there with your XT60. It's really not a bad idea. I could pick it up with the any of these test points though. I can solder directly to the test points. I don't have any PCB mount XT60s, but I can solder a XT60 directly to the board, which is another idea. That wouldn't be a bad idea. So did you make your own USB extender? Did you chop up 10 USB connectors, 10 USB cables, or did you order one of these and chop the end off and put an XT60? Because there are these, which you can make your own charging ends. Oh, it's not like you have a GitHub or anything. Actually, I'm gonna bring this in. Copy. Paste it into there. So I don't have to click through Chrome tabs. Okay, let's see what you got. USB PD. PCB. Oh, this is not good. How can I see it? So enclosure, yeah, 3MF. It's not going to help. You only have one photo. You use Eagle? Well, it's not going to open on my computer then. README. Meanwhile, oh, you're using like you're using a literal AC to DC 5-volt power supply and then plugging into this. I mean, that's a pretty good idea, I have to say. I didn't really want to order a power supply, but I have to say, it seems like you've come along and solved the issue I'm trying to solve for. Using an ATX? Then what's this Meanwhile thing? LRS 100XX. This guy. So LRS 100/05. Okay. I think I'm understanding. Damn, Johnny, you couldn't have just said that at the beginning of the stream, and then I wouldn't have had to go through all this trouble. I could have just downloaded your files, sent them off the PCBWay, made a video, credited you, and then I wouldn't have any issues at all. Mind you, I feel like I can make something similar because I ordered these guys. Give me a second. Yeah, Streamkiller for sure. PSU Molex 4-pin pinout. I think it brings 5 volts across. Yeah, it brings 5 volts across. So because I ordered these guys, I could actually use one of those as well. Whatever. You know what? I'm gonna do my own take. So it's okay. More designs are better than fewer designs. But what I might do is I might shoot out. Wow, I'm not American. I might shout out your project as well during the video, and so people can go check out yours as well. But my plan is I'm going to use that power supply to do more than one thing. So it's going to be over on another one of my workbenches that doesn't have power. And basically that power supply I'll use these guys to break out 12 volts, use the Molex to break out 5, and yeah. Yeah, of course you need to upload more. If you want something done correctly, you do it yourself. Yeah, this is, I have an issue right now where my channel is shrinking because I haven't been putting out any like sort of like published, like edited videos. It's more like mailbags and podcasts. So I need to get back to making projects. And I've got so many projects on the go that, yeah. All Ethernet switches and USB hubs are driven by that ATX power supply. Wow, that sounds horrible for a redundancy, on the redundancy aspect. One thing goes down, everything goes down. Also, did anyone notice how expensive computer power supplies are? Like, that's a 750 watt. This one's not too bad, 600 watt. Okay, good. It's good that you have a couple spares. I'm gonna add this to my wish list, in fact. But this is what I mean. Look at that. This cheap power supply, so $50 is pretty cheap for a power supply in Canada, by the way, can provide 17 amps on the 5-volt rail and 42 amps on the 12-volt rail. So this is what I mean, like these power supplies, you know, and the thing is, you can get some used relatively inexpensive. So I'm hoping people will want to use my project. But if not, I mean, whatever. It is what it is. Now, here's a question. Do I fuse these or do I not care? If I fuse them, I got to do a little bit of extra work. Not much, though. Let me just move you to webcam, just checking Discord for a moment. Oh, interesting. Just my wife updating me on something. Fuse it, better safe than sorry. Dang it. Why you guys have to be so right? Alright, so we'll just... It's more, I'm more worried about the 5 volt. So UF, and then I'm going to copy that and paste it over here. So UF just means unfused. And then if I have my custom parts somewhere. I'll have to look for my custom footprint that I made for my fuse holders. Okay. Well, Johnny, the thing is that if you look at this, I don't think the overcurrent will trip. Like there's 17 amps of 5 volts available. So I don't think the overcurrent will trip at like 10 amps, for example. You can put a 10 amp fuse in there. And you know, you can run multiple fuses for multiple channels. Yeah, if it shorts, then who knows, actually? That's a good question. I feel like maybe I'll leave the fuse out on this one. No. I'm going to put the fuse in because I'm going to tell people that it's possible that their power supplies that they find in the trash don't have good overcurrent protection. And what I'll do is I'll tell people you can short it with a piece of wire if you need it. Do you need electrolytic caps on each of the power ports to protect devices? I have no idea. Do you mean from like voltage fluctuations? Because I think if anything, it'll just fluctuate downwards, right? Because the power supply has output caps. So I don't think that they're going to go up over current. Actually, I think this one had even... Yeah, look at all the caps up here. I think it's okay. They have like, they usually have really big, a lot of output capacitance. Plus, I mean, they're designed to handle the amount of current, you know, and computers have very spiky power demands these days. So I think it's okay. Okay, so unfused to 5 volts. I think I shorted the 5 volts to the 12. Yeah, that's not good. Okay, so then we can edit this one. 12 volt unfused. Maybe I'll leave the... I don't want to put that many fuse holders on it. Whatever. Unfused, edit 3v3. What do you guys think of the new spec for power supplies where they're going to be 12 volt only? It's already in use. 2, 3, 4, 5. It's already in use at this point, but it's not like the most popular. Don't like that idea? Yeah, ooh, power adapters. That's the bad thing. You see, I kind of don't trust myself to not make mistakes. So hopefully, if I solder everything properly, it should be good. All right, so we got 5 volts, 5 volts, and I need the 12 volt to there. The 5 volts standby. 3B3. And negative 12. There we go. I think that's pretty much it. Yeah. Well, it's because on the computer, your motherboard already has the capability of bucking the voltage down. And so it actually increases power supply efficiency to only do one voltage rail. And when you carry a lot of current down a wire, if it's more voltage, you have less I squared R losses. So you get way better efficiency with the 12 VO spec. I think this is all good now. So let's annotate. I don't think is there anything else I need to add? And if before you say pink LED, this LED can be pink if you want it to be. It's really up to you. Can I copy that link? Copy link address. Let's see. Let's see what short we're getting. Oh. Why? I don't want to do this. No. I refuse. 12 pink LEDs. It would be nice to get a lit LED port. They do exist, but they're extra cost. I don't really want to add extra cost. LED USB connector. Oops, that was an accident. I don't even know how to PCB. I mean, how bad is this? Can't even find a freaking... Eh. Oh well. Oh. What's this? It's got a bump on it. Does that have an LED? No. Oh, that's PCB edge mount, I think. I should probably order some of these guys too. Facing straight up. It would be a nice, I could make a nice PCB box like Johnny Bergdahl's. I want a quad stack. Just literally, just a strip of LEDs, but in socket form. With Bluetooth. Yeah, no thanks. I mean, at some point I will be capable of writing apps. It's just I'm not at that point yet. It is coming. I'm doing Code Academy, starting with HTML. I have a little bit of C++ under my belt, but I'm going to do more. Okay, I think we're going to assign footprints. So first let's annotate. Haven't done this in a little bit. Annotate. Good. Footprint assignment tool. There are no footprints. Dang it. All right. So for the LED, I'm gonna go an LED footprint, but it's probably gonna be a remote footprint. So let's see, LED through hole, 5 mil. Oh, let's see. Look at the footprint. Seems good to me. Fuse. Part. No, not these. Custom. Custom libs. Screw terminal. Fuse holder. There it is. Fuse. Okay. ATX 24. Molex. Still places with 2G. Even Canada has 5G. None of these are correct. Is there an ATX library? Like, so what I don't like is this search doesn't let me search everywhere, right? Let's see, in the connector. Connector regular. These are ones I made. Might have to make some custom footprints. So connector Molex just was there. It should be a 2x12, 2x7. Might go looking on GitHub for it. 2x12. That's not it. Two by 12. Nope. So that's not going to work. connector pin. I can actually make the footprint pretty easy because KiCad is a wizard. But then it's to name all the things. Pin headers, RJ, SATA. Really? There's the friggin' footprint for one of those combination SATA things. That's interesting. Oh, there's USB. Oh, I might be able to find the stacked USB. I think that's it right there. Horizontal stacked? I don't know what that means. Oh yeah, that's probably the right one. That's cool. I don't have to make that, but the ATX one, it feels like I'm gonna have to make it. Wire connector. Interesting. Okay, so I'm gonna have to make, oh, maybe in the DigiKey. Let's see if they have ATX. No. Boo. Module. Adafruit. No. None of these. Mounting equipment. Huh. DIN rail. There's these SW things, which were custom libraries as well. SOC 523, interesting. Hello, Intel? Intel? No. Linear little fuse. Just curious what they have for little fuse. Okay. Test pads. Pogo pins. Interesting. Your phone is 3G and 2G compatible, but they're stopping 3G. Yeah, I have I'm gonna have a 5G phone. I actually have it here. Haven't set it up yet though. Yeah, so the ATX 24 pin, I'm gonna have to figure out a footprint for it. And look at all these freaking Cherry MX things I downloaded. Okay, let's get the USB stacks though. Connector USB. Where was it? Yeah, connector USB. I feel like they're going to be the horizontal stacked ones. So that looks like a regular USB. I feel like that's the ticket right there. I'm going to use these. If I have to modify them, I'll modify them, but I feel like they're 0.1 inch per hole. I might just send it. I'm going to be honest. All right. Should I go through hole for these resistors? I kind of don't feel like it. I think they should be 0805 SMDs. If you, if anyone's paying attention, what do you think? Is through hole that important to you? Especially for something that is just to bring the, to pull down to ground the data pins, even though it's not really necessary. What do you think? can skip that for now. RV1, we can go resistor. Resistor. Wait, potentiometer. THT. I have to see what I got. Can remove the USB resistors. Probably will then. Drop the board complexity down quite a bit. Through hole, give more stability to the socket. Huh? They're not going to the socket, they're just going to the data pins. I think this is it. No, that says vertical. I have to go check the measurements on some through hole. Because this, I do want this to be a variable resistor. I don't know what the switch is going to look like yet. The test points I do know. Test point. I like the biggest pad possible for the test points. They're used on the client side till the PSU should feed voltage. Oh, interesting. Oh, gotcha, gotcha. Okay, let's drop all these resistors. This is actually, I do love dropping board complexity. It just means I'll be laying less out. I did spend time doing them, but that's okay. The funny part is, I think I've got the right footprint for these stacked things, and if I do, I can send this out to be built like tonight. Okay, so those are gone. Do I have any other resistors? No, so that'll actually not change our annotations. So that's good. So just need the switch, the 10K variable resistor. What? Why not? I'm shorting them. Don't they need to be shorted? I shorted them on my test. They seem to work just fine. Ooh, all my GoPro batteries are charged. Do you seriously just leave them floating? That seems wrong. I mean, I'm no genius. Oh boy, I just dinged the frickin' camera. They are connected to different ports. Hold on, I just want to see how bad I ruined my webcam. So this one here is shorted. Move that a little bit. Move that a little bit. So this one's shorted and working just fine. You use Dual port connectors, yes. Look, I'll show you. So, see that? One port, the other port. And so what I'm using are these guys. If you see there, they have 8 pins. So this is one USB connector, this is the other one. I mean, I can't be 100% sure that's what's going on, but I've tried them floating and shorted, and all my stuff I was charging, including the Apple iPhone, was charging properly. So I feel like shorting is the way to go. I'm not, not 100% sure, but I certainly feel like it. I just bought these. I think I paid more than this for them, which makes me a little sad. Also, oh yeah, I wanted to check the sizing on, hold on a sec. I want to check the sizing on the potentiometers I'm going to use. So, I know that my potentiometers are breadboard friendly. So just bring in a breadboard. I'm just going to leave this charging because it's nice to charge my GoPro batteries. That should be done in the client side, tell the PSU what to do. But you're on the PSU end. Well, my PSU is dumb. Like, mind you, those are minor things. I can just disconnect them after. But, like, you just leave them floating? It sounds weird. These guys. So this is the potentiometers I want to use. And I think they are 5.0. Oh, these are vertical ones. Didn't really want vertical ones. One moment, please. Well, according to my experimentation here, floating or not doesn't seem to make a big difference. So I can just undo the floating. Like, I can just delete the links. That's not a big deal. I don't, if you're telling me best practice is to leave them floating, then I will leave them floating. But in my experimentation here, so far, it's been shown that they're pretty much the same. The PSU is the ATX, and you don't care what the client says by adding resistors or shorting. Okay, okay. Drink. Am I supposed to drink? What am I drinking? I don't have any. Pepsi to mix with my rum. Okay, so these are the pots I want to use, and so they're 0.1 inch. So they're 2.54. No, they're 5.08 between these pins because they skip one hole, and then they also skip one hole this way. So that's what I want to use. So that's what I'm going to do. Hey, focus you. Okay, but is it a problem? Like, does it matter? Like, can I just... So, okay, I'll just leave them floating, whatever. If that's best practice, that's best practice. All right, screen. There we go. And then I'll just do the not connected flags. Is that the way yours is set up with the pins just floating? There we go. Done. All right. So footprint assignment tool. And I'm going to open this. Then we get here. Here, RV1. So potentiometer. Potentiometer, THT. That doesn't look right. All yours are floating? Okay. I mean, the big thing for me is I can't, like, the turnaround time is massive, right? Way too big. So I don't want, and by massive, I mean I'm being a little princess, because the turnaround time is only like 2 weeks. But when I'm trying to get monthly builds out, it gets a little awkward. .08. That's 2.5 though. Come on. Do I have to make my own frickin' footprint for a potentiometer? Or is it called like a trimmer? 6V vertical. That's 5. And that's 5.08. Like that it would fit in there. Float on? Yeah, that might be before my time. Who's it by? It could just be a band that I don't really pay attention to. So this would work. It's not quite the right, but you can massage it. It depends though, 1, 2, and 3 pins. I don't know where the wiper goes, but between 1 and 2, I think it would work. I'm just gonna keep going on this. Oops. Really wish it doesn't have to be docked like this. There's another 5 there, and there to here, that's another 5. This would fit too. Kind of the same though. Oh, is this the one I was looking for? This is the one I was looking for. By the floaters. Oh, nope. Never heard of it. That's 5. And then if this is 5, yeah, this is it. Okay, so we actually will take this one. Done. Okay. 1 and 2. I think these two are this is the wiper, so I think we're good. All right, now what do I put as a switch? I almost feel like putting test pads, but I'll see what they have for a switch. What do I even have as a switch? I guess I have my custom libraries. Custom libraries. I have my own switches. I have that. Can use that. It's good. Now just need an ATX save. Just need an ATX power supply footprint. Okay, ATX 24 pin power supply connector keycad footprint. Oh, they have them on EasyEDA. I wonder if I can just download those. I just want the footprint. Okay. I guess I'll just make my own. Screw it. All right. 24 pin Molex Mini Fit Junior. Okay. DigiKey not working? Certainly looks close to it. That's the wrong gender. That is not it at all. Oh. That is very close. The one I ordered doesn't have little wings on the side. No peg. This is it. Oh, this is angled though. I want this, but no angle. This one has pegs. Mini Fit Junior. This is it. That is what I'm looking for. Sorry if I knocked the mic there. Okay. Oh, they got PCB symbol. Footprint. Can I? Oh no. That's a 3D format. That's not what I want. End up cutting wires I need off the plug. Well, I need the other end. Okay, can I? What's the? My God, this is terrible. I'm gonna look at the data sheet. Okay. So, oh, no footprint in the data sheet. What? What's wrong with you? 3D model drawing footprint? Oh, thanks. Oh my god. Okay. Wait, but if it's in there, why is it not in my DigiKey thing? Well, I've got some coming in the mail. I've ordered them. These guys. Maybe these guys have a footprint. No. Because honestly, sometimes AliExpress sellers are better. They just literally have the footprint. You know what? I'm going to go just KiCad footprint, images. Oh. All regions. Pin spacing is 4.2 plus minus 0.08. 4.2 what millimeters, I guess? KiCad for Molex 24. No, I checked. Because you get connector Molex. Connector Molex. Then you look for 2 by, here, I can just do a 2 by 12. Oh my god. Minifit Junior. They're right there. How did I miss them? Why 2 by 10? It's 2 by 12. It's 24 pin. Oh, 20 or 2 by 10. Yeah. So it's actually right there. As long as these numbers line up with, the numbers on the thing, we should be good. So yeah, they are. This is exactly what it is. Minifit Junior. Okay then. Well. Oh, that was stupid. I erased my LED. LED. THT. Oh, the search is still on. 5mm LED. Done. There we go. That's okay. Okay, so now I just need to make sure what pins are to what. I feel like this is going to be all good. Yeah, I used through-hole LED as well. So then it works as a solder pad. They did a good job assigning all these pins. Okay, so let's pick a couple of pins at random. So 7 is ground, 12 is 3.3. Oh, over here, 7 is ground, 12 is 3.3. My god. I do have the ATX pin out somewhere. 7, 3, 4, 5, 6, 7 is ground, 12 is 3.3. Yeah, I think they got them assigned properly. The connectors were 20 plus 4. Yeah, I know. So the key might be in the wrong spot, but I think they're good now. 1, 2, 3, 4, 5, 6. Yeah, it's in the middle now. Can you still get them locking caps for LEDs? I have some here, the locking caps. Yeah, because look, the 20 pin was offset, so it's still in the middle. So the 24 pin is all the way. We're good. And I want to make sure I have the ones that are coming are these specific ones, and it is 24. So we're good. Everything is going according to plan. All right, so that's done. And so that's it. Now we can just go to the PCB. So the maximum size I want on this edge cuts is going to be 100 by 100, but like ideally it'd be even smaller. Let's try to go within 70 by 70. There we go. There we go. Yeah, I know they work they work each other. All right, and let's update from the schematic. Oh, there's no way this can be 70. Look at how big those sockets are. Okay, let's see. Let's start with the important stuff. Let's get this guy. See if we can put it just about in the middle there. One, that's the switch. Switch doesn't really matter because it's going to be off the board. Yeah, I think a lot of PSUs are still +1, +4. I think J3. So like these sockets, like they can poke out, so that would be okay. See how many we can fit. 4, 5, and 6. Okay, we're gonna have to make it a little bit wider. That's good. Like so. Then 2. And dot in. Yeah, screw holes, huh? Okay, let's get this a little bit bigger. Let's see if we can draw on edge cuts. We're gonna go max size for width. 97, sure. 99. Let's go 99 by 99. Because like PCBWay sponsors me, I can literally go as big as I want. But I do prefer if people can get them for cheap. So that I try to do it within the PCBWay size restriction. Yeah, I won't be able to fit. I won't be able to fit them all in one shot with my 100mm stack. So 4. So yeah, I could do 5 across the front. or I can shrink this to be smaller and do 4 across the front. And then I'll be able to fit an M3 screw hole. 2, 3, 4, 5, 6, 7. 7. One more like that, and I'd be able to put a screw hole here. I'm actually gonna probably move them back a little bit so they don't stick out so much to make the arrangement a little bit more compact. Kind of like that. Between the 4 of us watching, we've got the likes up to 8. Yeah, that's pretty good. I appreciate the people liking the stream. It does tell YouTube that it's an interesting stream. I don't think it helps too much in promotion, but whatever. This channel is not really supposed to be for promotion, though. You know what I mean? It's just we're chilling. Okay, so we're gonna take this ATX. We're gonna move that over. Let's say there. The switch can literally go anywhere. I don't know. We'll deal with the switch after. That's not that important. Now, the 5-volt fuse is the most important. So probably going to stick that. Say the fuse should be close to these guys. Like so. You've had it recommended. Nice. Okay. So I think I'll be able to shrink the board vertically. So the LED can be kind of like over here. Could put it up front there to get the wires. Like if you want, you can stick it like stick it around. Okay, first and foremost, let's put some mounting holes. M3 to try to see where I'm getting at here. Take this. Oh, that's not what I wanted. So edit this. Don't need to show that. Don't need to show that. Okay. Move that into its spot. Let's say here. And here. So that means I can stick the LED here. That won't be in the way, and what you could do is you could bend the legs and stick it out over this way. So that's good. And then this resistor will literally go around here somewhere. So you can tune the brightness of the LED. So that's good. I'm going to do a ground pour on the bottom, so I'm not worried about that. Going to put them, where are these? One hole in like that. Oops. Like that. There we go. Mounting holes are done. What is everyone drinking? I guess it's pretty late for you guys. Everyone in England, it's already 4 plus 5, 9 p.m. Does that make sense? Okay, so that's fused. So basically all of this is going to be a ground pour. So I'm seeing I don't really need that much height. I'll be able to shrink this quite a bit. Because like this fuse essentially can go like here. And then this center area can be where all of these pads are. I almost feel like these test points shouldn't be set to these. They should be like a through hole test point, so I can use the back as a ground plane. I think I'm going to do that. Yeah, 9 p.m. in Britain, and Sweden would be 10 p.m. Since we know Mr. Johnny Bergdahl is in Sweden. Sweden. Okay, so I'm going to change the footprint on these test points to be something else. I want them to be, so these guys, delete association, yeah. I'm going to go up here and go test point. Oh, it's going to be drilled test points. A 3mm drill hole is kind of big. These are like SMD pads. Plated hole. Four by 4, same size, but with a 2mm drill hole. I think that's what I'm going to go for. All right. This and then update. It makes it so much easier if I just use a ground plane on the bottom or the top or whatever. If I do it this way. All right, so now we're going to move this plus 12 volts, 3.3. Oh yeah, I like that. Minus 12 volts. And this guy. There's a lot of space here, so I can actually space them out quite a bit more. So if I put that one sort of equal to this one, just kind of split the difference here. the best line up well? Yeah, they do. Just gonna move them a little bit so that they're symmetrical. That looks good. So yeah, basically all these can be, this can be test pad area in here. And then, yeah, that's gonna be as simple as it gets. And then I can move all this thing, like this resistor really could go on the side of the board. Or like here. This guy can be moved down a lot closer here. Oh, I lost my mounting holes because they're not part of the schematic. Whoops. Then edit. You work in fire control. That's interesting. I could put this right on the edge, actually. I think that looks good. Move that like that. Oh, this is backwards. Backwards. Backwards and backwards. There we go. My switch footprint is absolutely massive. Might just remove the switch and put test points, but then you can't switch on the board. Hold on a sec. What if I just move this offset like here? I could stick it literally right here. Move the text a bit to O and I. I think I'm gonna do that. I'm gonna put that there. Edit this to say on will be a 1. Off will be 0. So it doesn't matter if it sticks off here, it'll just be chopped. This is good. LED is here. And then I just need to arrange my 5 volts, move that like here. And then the next one is 12. Then the next one is 3v3. And the next one is PS on. I'll deal with that after. This is -12. And the other one is 5 volt standby. So I actually need to separate them out a little bit. sort of like so. This should be about equidistant. 4, 5, 5, yeah. Maybe I'll just grab these and make them equidistant. Distribute horizontally. There we go. So that looks good. And then these grounds don't really matter. I'll just put them. I'll flip it upside down so that I can put the text. There we go. Oops, forgot to flip it. Can't you have the power switch off board and mounted? Yes, but I want to put the pads there anyways, so that if someone just wants to use this board as is, it's still usable. I really want I want to think of all the use cases that I would be complaining about. You know what I mean? I don't know if that makes sense. Because the thing is, it costs nothing to add pads. So I even I have these extra footprints that I just put on because why not? Okay, so now the only issue, I can actually move this ATX thing in a little bit. So actually that looks pretty good to me. That looks very good to me. I might round the corners, but I could do that after. But this honestly looks pretty damn good to me. I'm going to do a ground pour first and foremost on the back side. So let's do that on the back. Do a ground pour. I can't believe it all came through like this. So I didn't want the USB sticking off on the sides, but this is actually ending up pretty nice, so I'm okay with that. All right, so ground pour, filled zone. So we want back copper and we want ground. Thermal reliefs is fine. Okay, we can pour that and see what we're looking like. Not sure what's going on here. Let's see, view 3D viewer. Okay, no, it is poured. The ground, these are grounded. That's good. Oh look, there's only a single thing that has a 3D image. I think that'll look pretty good. I'll have to put labels on everything, but still, it's looking pretty good. And the silk screen here will have to go, but that's okay. I don't mind. Okay, so that's good. You can undo that. Now, I'm gonna have to run some wires. This is gonna be a bit of a mess. Just trying to see if the ATX connector is better this way or flip the other way. I think it might be better flipped the other way. Ground, ground, ground. PS on. Yeah, PS on needs to go over here. I'm going to flip it. Okay, all right, let's try to run a wire now. Relatively thick wire. Let's go like 1.5. This might be a little much, we'll see. And let's run this on the front copper. I want to connect like the, oh, that's not big at all. 1.5. Kind of want to connect the ones that go together. Kind of like that. So this is a 5-volt board, so I want to run a relatively thick connection to 5 volts. Oh yeah, actually that's not what I wanted to do. Let me, I wanted to pour a 5-volt unfused pour on the top here. I remember now what I wanted to do. Okay, so we're going to pour 5-volt unfused. Okay, we're going to pour it across this way to here, to here maybe. No, let's do that again. I'm going to do in this corner. Okay, so like this. Where's the 5-volt? So really it's to here we want. So to here, let's do to here, to here, to here, there. Okay, so that'll connect only to the 5 volts. Yeah, it'll connect all of them together. Because this is a 5-volt board, that's the main deal, so that's what I want to do. Now we're going to run the other stuff we need. So 12 volts, that's only those two, so that's good. So we can exit this right away and come over here. And then this can connect to that. So that's good. 3v3, it's all here. That connects to that. That's easy. I might just switch the because I see the negative 12 volts is here and the 3 volts is here. I might just switch these two. So I'm actually going to delete that. Take this one, move to here. This one, move to here. This one, move wherever it was. There. That makes a little bit more sense. Take these two. Actually, it's just this one. Move to here. Move to here, and this one move to here. Makes it a little bit cleaner. No later than, I want to be done no later than 5 o'clock. I'm gonna have to eat, so what did I do? What did I do, Franco? What have I done? a negative 12. So if I just pour, that looks pretty good. All right, so we're gonna run. Oh yeah, this can go to here. That's done. This can go to here, and this can go to here. The left bottom pins should not be connected. These two? These two, 12 volt. Oh, I'm missing a 3.3 over there. The left bottom pins, yeah, these two. They should, why should they not? They're the exact same rail. 12 volt UF, 12 volt UF. Let's see. Grab. So this one here, 12 volt, 12 volt. Opposite side of the lock across. So it's pin 10 and 11. Pin 10 and 11. They're the exact same rail. Also, I think I'm going to delete this. I'm going to go with 2 mil traces. I want to get as much current as I can. And then these guys with these guys and these guys. What size plug is that? It's a 24 pin. ATX 24. I'm not using the 20 pin, it's too small. Okay, 5 volts. These three can go together. Oh no, wait, I'm doing ground pour. None of those. That does need to be dealt with. The standby is going to be a bit of a pain in the butt. Yeah, no problem, Franco. That's completely fine. I appreciate what you're trying to do more than dislike being stopped while I work. You know what I mean? Does that make sense? Uh, 0.75. 0.75. Oops. This the only one? This the only one? It means more that you wanted to try to save me from a mistake than the fact that you were mistaken. Don't worry about that. This guy, this guy. Oops, that's ground. It's not connected. All right, so just want to pour this and take a look. Let's say 0.75. The 5 volt standby only needs to go over there. And I think the power OK needs to go that way. So power OK comes down this way and then hits a via. Power OK is low current. right? So we're going to via through here, grab a wire on the back copper, go across to here, grab a via. This is low current, so this doesn't matter. In fact, on mine, it'll probably do very little. There we go. So that's good. And the PS on is the same thing. Low, very low current. So we're going to run that just up like so. And like so. Ground is already passed, that's good. And then the 5 volt, if I drag this, let's say like that. These are actually connected through the bottom, so don't need to worry about that. Give it a nice angle there. So then our, what was I trying to do? I was trying to run something. Never use the Power OK wire. What does it do? Johnny Bergdahl said that when the power is on the power supply, it sends 5 volts and, sorry, oh, the Power OK. Yeah, it sends 5 volts and you can use it to power an LED, which I will do. Oh, take my LED and flip it around. There we go, and that's going to be the ground, so that's going to be fine. What else do I have to run? Oh, the 3v3. Got to get that here somehow. I can leave this disconnected. It's not really that big of a deal. But I do have a high current path this way. Let's see. Okay, if I run it, actually I can run it around town this way because these don't matter. 5 volts will go through here. No, it does matter. Can run it down this way. This way, and then up through here if I drag this around. If I drag this here, drag this up a bit, drag this like that. I can go all the way out there, it doesn't matter. Actually, this one, can delete this and just drop this into here. Drag this up like so. And then I can run my 3v3. Sort of like that. Oh, this 5 volt now is not touching though. Ground plane. Yeah, ground plane is good. Oh wait, I still haven't moved this guy over. Okay, hang on a sec. Let's drag this guy up to there. Drag this up to there. Drag this guy up to there. Drag this guy up to there. Bring this guy down to here. That's not going to be a high current though. That's the only thing. Okay, hang on a sec here. If I delete this, delete this, delete this, if I go for 1.5, go up to here, via, and then I go back copper, to here, and then I go via, I go front copper, to here and here. Okay, that's good. Again, not high current, but decent. And then this guy to there, and then, oh, actually, probably want to do as big a wire as I can. So I'll grab a 2 mil. This to there. Oops, this to there, and then this to there. We'll probably want to avoid that, like so. Okay. So still have this ground here is stuck. No, this 5-volt UF is stuck. Okay, so if I drag this up. All right, so let's see. Delete this. Okay, so if I take this up, oh, can't go through here. Okay, I can go on the back side for this. Oops. So if I go around the back, because the ground plane doesn't have to connect necessarily to here. Yeah. There we go. Is everything connected now? It certainly seems like it. That's a not connected, which is fine. Might move this in one. No, I'll leave it. It's fine. Leave it, leave it, leave it. Okay, so okay. These should be, oh yeah. Now, the other thing I wanted to do is pour a 5-volt here, all across here. So if I go here and then pour, that's what I wanted to do. From here and then +5 like that. And it just, I don't really need to be conservative about this, can just go all the way across like that. Oh, are these touching? That shouldn't touch. I'm gonna move this down 1. I kind of want this up 1 though. So that should be good. See, but that only has 1 spoke. That's not good. All right, let's change my grid to half of what it is. and grab this and move it up one, and grab this and move it up one. That should be a little bit better. I'm going to change the spoke settings on this though. Get the 3.3 over the top. Yeah, well, could do over the top, but I wanted to leave the 5 volts connected. Now, do I go nuts and go no thermal reliefs? Oops. Solid. That's what I meant. So that is going to be a lot more high current, but it'll be a bit of a pain in the butt to solder. I don't know if I want that. I'll put thermal reliefs. Spoke width, we're going to go 1 millimeter. I think that should be okay. 1 mil here, that should be plenty of copper. That should be good. I think this guy should have same thing though. One. There we go. Can move a lot more current through there. Actually, this one should be a bit more. That one should almost be solid. Yeah, so that'll be a little bit of a pain to solder, but it won't be too bad. No, these are all solid. Yeah, that's good. A lot of copper there. I think that should do. Yeah, I mean, it's not too bad. You just get the iron nice and hot. I've done it before. Not too concerned. But that looks good. Let's look at in the 3D viewer. I mean, it's pretty. I kind of feel like pouring copper here, whether it be a ground or picking one of these things, because I just want my copper back. I hate wasting copper, right? This is all just going to go away. Me too. Actually, it came out looking pretty good. Oh, I'm going to round the corners too. I'm starting to hate the feeling of hard corners on my poor little fingies. So we go center that to there. That center that to there. And then center that to there. Then center that to there. And then you take this, you delete it, and then you just make new lines from there to there, from there to there. And basically now all we have to do is some labeling and we're good. One of my lines isn't connected. Don't know which one. Whoops, that's on user drawings. That's why. This, 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 and this, and this. Can you move them? How do you move them down to... Or is it just you go edit? Maybe you need to do it one at a time. Edit. Oh, there we go. Edge cuts. You do need to do one at a time. Edit to edge cuts. They should know if everything you selected is on the same layer. They should allow you to just move it. Or there should just be a thing, move everything to area X. You know, who cares if it's a mistake? You can always Control Z. Edge cuts. Edge cuts. Edge cuts. Edge cuts. All right. There we go. Now it's looking proper. Let's take a look in the 3D viewer. Looking good. Just got to change the text of all these. Remove the J's. Don't need the J's. Power LED. Can remove the text up there. I can remove the surround here too. Okay, so take this, edit, and then edit footprint. Don't need this. Gone. Don't need this. Gone. Actually, I could just show them. Okay, save. That's good. And grab this. Edit. Not visible. Done. This. Edit. Not visible. Okay. Edit. Let's go 10K. Change that. The 0, 1. I'm gonna leave them there so they're visible. Don't if you're still here, Franco, when I'm done this, can you also remind me to pour some more copper in here, please and thank you. Reference TP8. That is plus 5 volts. TP12 edit plus 12 volts. TP2 edit negative 12 volts. TP4 edit plus 3 V3. TP6 is 5 VSB. Okay. They're still centered, right? That's centered, yeah. Good. All right, let's pour some copper. Let's try to do it in a cool way. So I'm gonna remove this. And I'm gonna pour, let's see. I'm gonna pour 12 volt UF. Unfused 12 volts. Go about halfway to here. So like to there, and then to there. And then I can use this with a what did I do here? Oh, it's touching. Need to go down one. Now I can grab this and put a wire literally to anywhere. There. There we go. So that's now connected to that. I'm gonna do another pour. This guy. We can go up here. And I want this to be negative 12 volt UF to there. Say to here. I wonder if it'll connect it. I'll just put it all the way up to here. Doesn't matter. To here. To here. Actually, you know what? I will ground pour the ground. Yeah, I'll put this down to here. And I'll ground pour these guys. This wire, just drag this like this. Good, I'll ground pour that. 3v3. I'm gonna go like here. 3v3 UF. Up to here. Gonna go all the way to the edge. I don't really care about the 5 volt SB. Nah, we'll do the 5 volt SB. Never mind. To here. Say to here. To here. Then to here. There we go. Can actually delete these wires now because I have even more. That's good. And then probably just going to ground pour this. The standby voltage is fine. So let's do another ground pour. Be useful test points. Yeah, if you expose the copper. Ground. I don't know how much it'll pour here. It poured a bit. That's good. I'm just going to ground pour this. Don't really care. Ground to here, to here, to here. There we go. This is all my copper is saved. Didn't want to get rid of my copper. This doesn't look centered to me. Neither of them is centered. I need to get the grid changed. Oh, this is not going to go well. Nah, it says it's centered. I'm going to leave it. I'm not going to mess with it. Back to quarter grid. Oh yeah, and these are all ground. Whoops, that was terrible. Slightly concerned with arcing. No, it should be fine. The for DC work, the default the default clearance is plenty. Not a lot of potential between 12 volts and ground. Okay, that's good. That's connected on the back. That's fine. Actually, I should probably make this, the spokes on this guy a little bit tighter too. I think that's perfectly cromulent. Let's see what it looks like now. View 3D viewer. Looks pretty good. Looks pretty good. I'm gonna get rid of all these J's, don't need these. That one either. Okay, we're almost out of time here. So let's edit this, don't need the J. 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 This one. So we just need to write a little bit of text. And we should be good. So I want the, on the front mask, I'll write some text. USB charge O-Rama. All right, gotta center this in between these two. We're gonna change the size to 2 with a 0.4 thickness. Well, that's too big. 1.5, 1.5. Okay, that's fine. Oh yeah, that looks good. And then we want to, that's not what we want. I want to do like that, and then change sides, flip, view 3D viewer. So that's what it's going to look like. And then we flip it around, and it looks the same. All right, next. We're almost out of time. Got to go eat. So we want to put the labels for what we're fusing here, and I have to put it on the silk screen this time. All right, so front silk, oops, text. This will be 5-volt rail. Probably go 1.5 on that text. Want it right in the middle. 0.5, 1.5. We want to maybe 0.3. There we go. I need a smaller grid. Move. Maybe like there. And then we want to copy. Same thing, right where the fuse is. Right where the fuse is. Right where the fuse is. Right where the fuse is, and then we just edit this one. Standby. Edit this one. 3 rail. Edit this one. Negative 12-volt rail. Edit this one. 12-volt rail. There we go. I think this will work just well. Got big spokes everywhere. Should be just fine. What color do you want them? Any of these colors? Yeah, all the ground planes are done. So green, red, yellow, blue, white, black, purple, matte black, matte green. I'm not going none. I need some solder mask. Red, red it is. That's the color I'll order it. So red with white silk screen. And I'm gonna, I don't know. I don't feel like paying customs anymore, so I don't think I'll go immersion gold, but I will I'll take the option for, you know, possibly immersion gold. Well, red or yellow, which one do you want? So yellow would be with black silk screen. Actually, because actually it has to be a darker color because I made the text is in the solder mask. So red with white silk, and then this will show up nicely. I think that should work just fine then. So that is done. Control S. Saved. And you're gonna get to see it whenever it gets made. So that is the end of the stream, folks. Thanks everyone for watching. Thank you for lurking, if you're lurking. Thanks for the views. Thanks for the chats. I really appreciate it, and I hope to catch you on the next one. So next one will be next Monday. So this coming Monday, either playing Gran Turismo, or if the PlayStation lags too much, then it's going to be playing Assetto Corsa. And then after that, next Thursday will be this kind of stuff again. So also, if there's anything else you want me to make, I'm always taking suggestions. And who knows, if I'm off tomorrow, maybe I'll do another stream in the morning. I have heard nothing from my new boss yet, and he is pretty damn good on communication. So who knows, maybe I'll stream tomorrow morning. We'll see. Thanks everyone for watching. Catch you on next week. Same bad time, same bad channel. Thanks for watching.